So today we are going to talk about something that's called a multiplier. 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 All right. Today is December 1st, 2021. When you are going to study, self-study, or study wherever the pipe bending and pipe fitting and whatnot, we're just concentrating on EMT, like electrical metallic tubing, but that also applies to the other types of piping, including plumbing. However, that the plumbing and pipe fitting, it's more, I would say, it's more like advanced pipe fitting here. Now, we're just going to talk about something that is called a multiplier. You're going to hear that term a lot, and you're going to say, what is it? What, because, some of the lectures you're going to say, okay, we need to do this offset or three-point saddle or whatever. So we're going to use 30 degrees and the multiplier is 2, right? So, and you're going to always say, okay, stop, what is the multiplier? All right, so let's take care of this multiplier, right? So we'll talk about the multiplier and how to use that and why do we need to know that and why do we need to use that. And we're also going to talk about some of the shrinkage that has to do with the pipe. But let's take care of the first things first, right? Okay, where is my first page? Here is my first page. We're going to have a little tiny bit of a background, but not too much. Control L. Here is my full screen on my do we have that here? We still have that. All right. Wow, we get some screen changing things going on here. All right. So basic trigonometry, right? It's a type of gonometry that has to do with trees. So it's a trigonometry. Funny. All right, so here we have a right angle. And let's say we're going to not talk about the right angle, but we're going to talk about the angle that is right here. And of course, as all the other angles that matter, we're going to call it a theta angle. Who cares what we call it? This is the angle that we're going to be using for bending the pipe. Anyways, so when we talk about the triangle, right angle triangle, if this is the angle we are interested in, this side of the triangle is called the opposite. Okay. The one side that touches that angle is called the adjacent, and the longest part here, it's called the hypotenuse. All right. Now, the 6th till the 10th. Okay, 30 degrees. I'm reading the chat lines here. Okay, cool. All right, so we have the functions and the reciprocals here. Now, remember this SOHCAHTOA thing here? Here is this SOHCAHTOA. That's not some sort of a exotic princess or something name. It is an acronym, right? Sinus or sine, cosine, and tangent, right? The sine of the angle here is the ratio of opposite to hypotenuse. So we divide the opposite and the hypotenuse, and we're going to get the sine of this angle. Cosine is going to be adjacent here to the hypotenuse. Excuse me. And the tangent, we're going to go with opposite to adjacent. So that's basically where the trigonometry comes from. That's the basics of trigonometry, right? Now, there's the functions and the reciprocals. Now, sine is the opposite to the hypotenuse. And then if we reverse that, we're going to get something that's called a cosecant. All right, now, it is the reverse of sine, so it's 1 over sine. Right? Same thing with the cosine, we get the secant, and then the tangent, and we get the cotangent. Follow me so far? All right, so here is our background. Do we have anything else on this page? No. Let's move to the second page here. Now, when it comes to bending the pipe, I have kind of faded out the hypotenuse adjacent and the opposite because there's slightly different terminology that we use when it comes to, excuse me, the pipe bending. Right? Hopefully this thing didn't burn your ears when I did a little throat clearing. All right, so the hypotenuse is called the travel. The adjacent is called the advanced or the advance. And the opposite here of this angle, it is going to be the offset. So obviously we're going to do some, we will talk about the offset bending. What is an offset? Well, if we have to bend a pipe, here's our pipe, right? And here's some sort of an obstacle. We're going to have to overcome that obstacle by creating something that's called the offset. Where do we have our angle? Well, here's our angle, and that's the hour angle that we're talking about. Okay. So we're going to bend that pipe, let's say 30 degrees, or you can do 60, or you can do other angles as well. And then we're going to have to bend it back the same amount. Right? And when we do that, we're going to end up with this line here, that's the tail. Here's the travel. And here is the head of the offset. And here is the height, which is the offset. We're overcoming the height. Now, remember, anybody has used stairs, if you have stairs, these are not very straight stairs, all right? If you travel only so much, let's say the stairs are under a certain angle, if you travel so much of the stairs, on that stairs, you're going to end up at a certain height. You keep traveling further, you're going to end up at a different height. Okay? So depending on the angle and how far you travel on these stairs, you're going to reach a different height. So in order to calculate how much travel do we have to make between this point and that point, in order to add under whatever angle we choose, we're going to have to calculate based on the height and based on the angle. We're going to have a certain travel distance, not further, not closer, exactly the amount, in order to reach that height. So that's why we have, like, imagine this is the pipe. Oops, wrong mouse. Imagine that this is the pipe we're dealing with, and we're going to have to use whatever angle that we choose. And based on that angle, we are going to calculate the distance that we have to travel. Why do we need to know the distance? All right, the reason why we need to know the distance is when we have a straight pipe, yeah, and out of that pipe, we're going to make something like this. We're going to make an offset. Right? We're going to need to know how long this is. So from this point, that distance is actually going to be that we're going to make 2 marks. And then we're going to bend it under this angle, and then we're going to hit that mark on the arrow of the pipe bender. We're going to bend it again 30 degrees, and that's how we're going to end up with this proper height of the offset under the certain angle that we choose. All right. Follow me so far? I hope you do. All right, so how do we calculate that distance? Well, we're going to come up with something that's called a multiplier. So follow me with this. I'm just going to make myself smaller a little bit here. There we go. We are going to use the cosecant. What are the players in this scenario here? We are considering the height of the obstacle, which is going to be called the offset distance. and we have the angle. And we're going to have to find out what this one is. So follow me on this one here. Some of us already know what's going on here. The cosecant, which is the inverse of a sine of this angle, is the multiplier. Okay. So the cosecant is the multiplier. A multiplier is a number that we're going to use to our advantage. Okay. So the cosecant is the multiplier. The multiplier depends on the angle of the bend. So if it's a 30 degrees angle, we're going to have certain multiplier. 60 degrees, 45 degrees, or whatnot, you're going to have a different multiplier. It is the 1 over sine, which is the cosecant. The multiplier depends on the angle of the bend. The angle of the bend is chosen by us. So we choose that angle, and then we calculate the cosecant of the sine. So let's just see here what's going on. For 30 degrees, where's my camera? Here, all right? Here's my calculator. Zoom in a little bit. Do I have enough light? There we go, now we have enough light. Turn that thing on, and let's get some focus going on. Good, all right. So let's say, okay, my calculator works this way here. If I want to find out the sine of the of 30 degrees, I just press the sine, and I go 30. Your calculator might work different. Sine 30, and I press equal. And oops, sine 30 equals. Now, and that gives me 0.5. Right? Then all I have to do is reverse that. Where's my reverse button? X to minus 1, which is 1 over that. All right, so if you go 1 over 0.5, we're going to get 2. So for 30 degrees, our multiplier is 2. Let's just recap a little bit. Multiplier at 30 degrees equals, all right, lower the light a little bit. Yeah, that's better. Okay, so what do we have? The multiplier is 1 over sine, right? Equals 1 over sine of 30 degrees. So let's say sine of 30, this is what we did. I'm doing this thing on purpose. I want this thing to settle in you, all right? Settle in. Okay, so sine of 30 degrees equals 0.5. That's what we have determined, right? So 1 over sine of 30 degrees equals 1 over 0.5, which is 2. So the multiplier at 30 degrees is 2. Now, how are we going to, is 30-degree angle we are bending the pipe to? We're looking at the 30 degrees. 30 degrees is one of the angles that is preferred by a lot of electricians when you're doing the pipe bending. I'm going to stop here. I'm going to answer your question here. Why do we use 30 degrees a lot? When you have a pipe, And let's say this is 30 degrees and 30 degrees here. Imagine you're going to have to pull a bunch of wires in that pipe. So you're going to come to this bend right here, and when you're pulling the wires from this side, you're going to come up with some resistance here, and then you're going to be some resistance here, and then hopefully you're going to be able to pull the wires through that pipe on the other side by feeding it from one end and pulling those wires on the other end using a pull string or a fish line or whatnot. The easiest would be to pull the wires through the straight pipe because or conduit, because it's the least amount of resistance. As soon as you start adding angles, you are adding some friction here. There's a friction point and there's more friction right here. So you got 30 degrees that you have to overcome. Right? Now, the more angle you put, like 45 degrees and 45 degrees, then you go all together, you're gonna have a 90 degree because 45 and 45 is going, so it's gonna pull harder. The longer the wires and the steeper the angle is, you're going to have a harder time pulling those wires. And that depends on how many wires, how thick is the pipe, not always ½ inch. Most of the time you're going to go 3/4 inch, maybe 1 inch, maybe even 2 inch, right? And then there's going to be lots of wires. Sometimes you're going to pull like 12 wires through a pipe, or maybe more, maybe 20 wires through a pipe. So that's why 30 degrees is kind of the best compromise. Now, when we did the box offset, we just used 10 degrees just because, for the box offset that we did. So that's why the 30 degrees is pretty much the most preferred angle for pipe bending when it comes. But sometimes it depends on the situation. You might have to use a different angle because the less the more gradual angle you use, the more flat angle you use, the more space you take. Sometimes you don't have that much space. You're gonna have to use a steeper angle to basically overcome some space. You're gonna find yourself in different situations. Right? No problem. All right. So back to the multiplier. We just found out that the multiplier for 30 degrees is 2. It's always going to be 2 because there's only one possible answer for the cosecant, or 1 over sine. 1 over sine is easier to remember, but you can use the cosecant. But 1 over sine, that's going to be a multiplier. So we choose the angle. All right. The distance between the bending points, remember, you're going to have to mark those points, and you're going to bend that and bend that. So bend 30 degrees here, if this is the front of the conduit. So we, just like we did the box offset, we bend that 30 degrees and then the whole thing back 30 degrees, and we're going to end up with something like that. Those two lines are going to be parallel. So that's why we need to know this distance, because if we make it longer, we're going to go higher. If we make it shorter, we're not going to clear the obstacle. Oops, there you go. If the chosen angle stays constant, the hypotenuse, or the distance between those 2 points, will change depending on the height of the obstacle. So depending on how high we want to go, we might have to choose a different distance between those 2 bending points. So here we go. The hypotenuse, or the cosecant of the angle. So hypotenuse equals the cosecant times the opposite. That's if we derive the formula from this here, the hypotenuse. If we want to just isolate the hypotenuse here, we have to multiply this side of the equation by the opposite. And in order to get the same thing on the other side, so the equal sign is kept, then we're going to have to multiply the other side by the opposite. So that's why the hypotenuse is the cosecant, or the 1 over sine of the angle, times the opposite. And the opposite is right here, the height. So you might as well get the answer right now. If you want to find out the distance between those points, which is the hypotenuse, once you find out the multiplier, which is 1 over sine of this, you take that multiplier, multiply it by this height, and you're going to get the distance between those 2 points. And all you have to do is apply the bands according to the chosen angle. All right? So the distance between these 2 points equals the cosecant, which is the 1 over sine of the opposite. The distance between the band points basically is the travel distance, or the hypotenuse, equals to the multiplier times the opposite, which is the distance. I'm just kind of rewarding this thing as we go. The distance between, this means that the distance between the band points equals to the multiplier times the height of the obstacle. As simple as that. We need to find out how long the distance is going to be between those 2 bending points. We find out the multiplier, and we use that multiplier to multiply that with the height of the obstacle, and we're going to get the distance between those 2 points. And then here's that statement and a half on the bottom here that I did. The multiplier. We use the multiplier to determine the travel distance. Remember, there's the travel distance. Based on the bend angle and the height of the obstacle, or the rise. Sometimes this is called the rise. How much do we rise here, okay? Multiply the offset height by the multiplier to find out the travel. The travel distance is the distance between the 2 bands. That's how you make the 2 marks. Right. So let's just find out if, okay, we just found out that what is the distance between those 2 marks that we want to do if we need to clear the obstacle. That is 3 inches here. Let's say we have 3 inches. Have to go up 3 inches. Right? And we use 30 degrees. So what we did, find out the multiplier. We just found out that sine over 30 degrees is 0.5. Flip it around, it's going to get 2. Multiplier is 2. We need to find out what this distance is, which is this distance, so we can bend the pipes. Multiplier is 2. 2 times the height of that is going to give us 6 inches. Multiply this multiplier by the height of that. I'm going to get 3 inches. Sorry, 6 inches between those 2 marks. So over here, it's going to be 6 inches, or make the mark between here and here, 6 inches. Cool. All right. Now, what if we need to overcome 6 inches? What is going to be the distance? Of course, yeah, it's going to be 12 inches. Right? So now, let me show you something. I put those pipes away here for a second. Calculator here, and I have 2 pipe benders here that I have. Now, one is Klein, one is the ideal. Right? We have a bunch of ideals in the in our lab, in our shop. But I bought, these are my personal ones. I bought 2 of those just so I could demonstrate some things properly for you, because these are probably the couple most popular ones. There's some other ones as well, but you can see those a lot. Now, on this handle here, for let's say the Klein one, All right, there is some little chart. Now let's see what that chart says here. That's for the offset. That's the offset chart. Okay, so we want to clear 3 inches. We're going to make an offset and clear 3 inches. Oh, look, we don't even have to calculate. Oh, guys, I wonder if you're getting some noises, some weird noises. Hopefully not, but my cell phone was in my pocket, and it was close to the microphone cable, so yeah. All right, I apologize for that. Okay, so let's say we have, and I just found out because I got a text and I go, oh my God, my phone is in my pocket. All right, so 3 inches of height. We calculated that we have to make the distance between the bands 6 inches if we use the 30 degrees angle. At 30 degrees, all right? And the pipe is going to shorten 3/4 of an inch. Let's kind of put that in the back burner, all right? Now, let's say 3 inches, 10 degrees, there are different degrees, so, but how the heck? We want to clear depth offset, 3 inches. 30 degrees, yeah, 3/4 of an inch. So this is how this table is made. Want to clear 6 inches, and it doesn't show you the 30 degrees here, does it? All right. So this is the chart, but if you don't, there's a little bit of a cheat sheet here on the handle. It's a sticker. Right? This is 1/2 inch AMT. Now, let's take a look at the ideal one, because it also has a little bit of a chart. And I'm going to flip it around here because all right. There's that. Let me zoom in a little bit. Can I zoom in? There. Okay. Let's see here. We want to clear 3 inches of an offset. And here's the angles. 30 degrees, 45, and so on, and 60, okay? And some of them don't have the numbers. But let's say 3 inches at 30 degrees. Now, it doesn't explain what it is, but now you will know. To clear the obstacle, it's 3 inches. You need to make the marks between those two bands. At 30 degrees, you're going to make 6 inches, and the pipe is going to shorten 3/4 of an inch. If you want to clear 6 inches, oh, we calculated we have to make 12 inches marks between the, and those things are, after a while, just going to remember that. But it's like a little gimmick, kind of a sticker. Good learning tool. All right. You just put that thing in a way that is not going to fall on us here, because it's going to make a lot of noise. All right. Now, what is the thing with the shrinkage or the shrinkage? Let me just because I want you to learn. The more you learn here, the easier it's going to be for you when you start doing a little bit more complicated bands and fittings in those cubicles that we have, those 2x4 cubicles. And there are some obstacles you're going to have to overcome, and you're going to be required to make certain types of bands and install them and run wires in them. Right? Just a reminder, tomorrow, whatever section it is tomorrow with me, but we have the the last lab, the three-way switch. All right, I think we're good. So we just found out the multiplier. The multiplier is 1 over sine of the angle that we have. All right, and what do we use that for? We use that to multiply the height of the offset based on the angle. All right. Now, let's talk about the shrink. What is a shrink? It says the conduit is going to shrink so many inches or so much. Is it that the pipe is made of rubber? It's not made of rubber. It's not going to shrink its all total length, right? What they talk about is that's why this thing doesn't write properly. When you have a straight conduit, it is going to have certain distance to it, certain length. If you take that and you bend here and you bend here, you're going to come from here to here. It's going to be a little bit shorter. The whole kind of like a straight distance, the projection distance. All right, because we are bending it, so of course we're going to shorten it a little bit. So this they're talking about from the start to the end of the conduit in that way, all right, the horizontal way. So the distance from here to the end of the pipe, if you project the light from the top, you're going to have the imprint of that pipe, or the shadow of the pipe is going to be shorter by a certain amount. Why do we need to know that? Well, sometimes you're going to have to do not just an offset to clear the obstacle, but you're going to have a certain distance between one box, and then you're going to have to do an offset, and there's going to be another box, and it's going to be a certain distance from here to here. So then based on that, you're going to make your marks. Yeah, you're going to know what's the distance between those two marks, but it's also important for you to know where to start making those marks, how far from the end of that conduit, so the whole length, total length from here to here is going to be what you want. All right. Okay, so let's see what the calculate. So multiplier, we know that is the 1 over sine, which is the cosecant, but 1 over sine, kind of easier to remember. Let me just kind of is the colloquialism of the times now. This is 2020, 21. Everything is kind of, and I apologize for getting myself caught in the whirlwind of that. In the 80s, there was really, everything was really, really, or don't be ridiculous. Everything was don't be ridiculous. And right now we got kind of. All right. Or kind of, yeah. All right. So the shrink. We're trying to find out how much shorter this distance from here to here is going to be after we perform the bend, right? It's going to come down a little bit, right? So that distance here. All right. And here's the formula that unfortunately you're going to have to. I'm not found of. I'll have to derive it for you. And to be honest, I had to ask for assistance, Mr. Lyons. We had a good conversation with that. But here's the thing: sine of the angle over 1 plus. Oh, I'm dripping here with the 1 plus cosine of the angle. Here's your formula. All right. Now, this here is per length. Dripping. My marker is dripping. Right, so let's see if we can come up with that. What was it that we had at 30 degrees? Oop, that's wrong here. Where am I? At 30 degrees, what did we find out? That we're going to have, at 30 degrees, 6 inches of travel, and the whole length is going to shorten. They are giving the final answers here, all right? So the pipe is going to shorten 3/4 of an inch. Let's get to that, right? So we already know at 30 degrees, we already know the travel distance. Let's find out the shrink. That's why I just keep shaking that thing. All right. So for let's go at 30 degrees. Okay. So we already know that the travel equals 6 inches. So we know that. Let's see how much. We know it's going to shrink 3/4 of an inch, but let's see how we can get to it. All right. So 30 degrees. At 30 degrees, sine 30 over 1 plus cosine 30. Let's just do it. Let's just not have any shortcuts here. All right. Wrong camera here. We see it? We can still see it. Buggers. All right. So we already know that sine 30 degrees is 0.5. So let's put that on there. 0.5. And then cosine of 30 degrees. Let's go with that. Cosine 30 equals 0. Let's say 0.87. You see that? So cosine equals 0.87 right here. 87. So add 1 to it. We're going to have 1.87. Let's calculate that. What number are we going to get? All right. 0.5 divided by 1.87. Kaboom. We came up with 0.26. 0.27. 0.27. Now, that's pair length. And since we're using inches for our length, so it is going to be per inch of what? Of rise. All right. So that's going to be per the offset length, per height. So let's see, we're going to clear 3 inches. So the under this angle and the 30 degrees angle, and this, the travel is 6 inches. Let's see how much that thing is going to shorten here. So 0.27 times 3, all right? Times 3 equals 0.27 times 3. That is going to give us 0.8. That is going to give us 0.8 of an inch. But what's the problem here? Anybody? Not a huge problem, but there's a little problem here, little challenge. On our tape measure, we don't have, gotta convert. On tape measure, we don't have the metric kind of a system. It's just metric, everything goes by 10, right? 1 meter has 100, 100 centimeters, and centimeters have 10 millimeters, and and things like that, right? And 1 meter has 10 decimeters. 1 decimeter is 10 centimeters, and then 1 centimeter has 10 millimeters. Everything goes down by 10 by 10 by 10. So, well, we're looking at the 3-inch, all right? You can calculate the same thing quickly. We're going to do for 6 inches. See if we can come up with the same thing. We should. Right? So for 3 inches, the pipe is going to, for 3 inches of rise, we're going to shorten that whole distance by 0.8 of an inch. Let's see if we can come up with 3/4. Well, 3/4. So how many quarters of that? You just multiply, forget that 0, because that's whatever the number you have, but we have a fraction here. So how many quarters? So 0.8 times 4, right? It's a trick. Yeah. Times 4, because we want to see how many 4 or quarters of an inch. So times 4, and that gives us the number here, 3. So that's 3/4 because we multiply. It's a trick here, okay? So remember that, times 3, so it's 3/4. We want to have find out how many 8s, all right? 0.8, because that's the distance that we had, times 8. That is going, and you look at the whole number here, the closest to the whole number. It's 6/8, which is going to be 3/4 or 3/4, all right? So the shrinkage of that is going to be 3/4 of an inch. Cool, eh? Yeah, we could do that too. All right. So let's see. Let's confirm. All right. To clear 3 inches of a height, when we do opposite, under the 30 degrees, we have to make mark 6 inches. We calculated that, and the pipe is going to shorten 3/4. Let's see if we can do the 6 inches here. All right, 6 inches of height. So we know that is we are going to have 12 inches of travel, and the pipe is going to shorten 1.5 inches. All right. So let's see here quickly. Let me just erase. Well, if you want to be real, I guess you could, yeah, if you want to get real exact. The only thing is, well, once you start bending, and I encourage you, if you're serious about that, buy your own pipe bender. Decide whether you want to go Klein or Ideal. I still can't make up my mind. Sometimes I like Klein and I hate Ideal. Sometimes I like Ideal and I hate Klein. Not hate, but I prefer one over the other. They're both good. I love them. I'll hate them. All right, let's quickly do the 6 inches offset under 30 degrees. And it's going to work with different degrees as well. But here's the thing. Do you want to get any steep angles? Sometimes you have to, right? But do you want to? Right, so we have at 30 degrees, all right, then the offset equals 6 inches. So let's find out the multiplier. Okay, the multiplier we already know, because the multiplier is 2, because we calculated that, right? That's 1 over the sine of the angle. All right. Now let's do the shrinkage. Shrink. All right. We still have a couple of minutes. The shrink. All right. So it equals 1. No. See, I'm trying to rush now. Sine of 30 divided by 1 plus cosine of 30. We just did that, right? I just erased that thing here, right? So let's just quickly here, 0.5 divided by 1 plus cosine, what was that? Cosine 30, 0.87. So 1 plus 0.87, so it's 1.87. What did we get? This is 0.5 divided by 1.87, 0.26. That's not what I get. 0.5 divided by 1.87. Yeah, 0.27. Right? It was 0.27. All right. 0.27 per inch of rise, so times 6 now. Times 6. That's going to give us 1.6. 1.6 of an inch. All right. Keep getting texts here. All right, so what do we get for that? For 6 inches? 1.5. So 1.6, well, we don't even need to do that because we're going to get the closest one. So 1.6 is the closest thing on the tape measure, 1.5. All right, so 1.6 inch, 1.5 is the closest thing on the tape measure that we're going to come to. All right, so that is the lesson for today. So now you should be able, you might want to watch this couple times. It's almost an hour. Just as a recap, all right? Whenever you're going to get some, things. As a recap is, what's a multiplier? A multiplier is the 1 over sine of the angle that we're going to use. And we're going to come up with a number. And that number, if we multiply by the height of an offset, we're going to find out how long is the distance between those two marks that we have to make, those two bending marks, the bend marks. The shrink, we got the formula, sine over whatever angle plus the 1 over 1 plus the cosine over angle. That's the shrink per inch of rise. Right? And I'm going to leave you with one last thing here. All right. How is that information that we just got, the multiplier, and the shrink, how is that going to apply to a 3-point saddle? Oh, look at that. I'm wearing a coat hat. And how is that going to apply to a 4-point saddle? Based on that information right now, based on this information that I gave you, can you calculate the shrink? Just look what we have. We have some triangles here. Now, the 4-point saddle is basically 2 offsets. So see if you can come up with some ideas of how you would calculate, because 3-point salad, if you use 45 degrees or 30 degrees saddles, then you just have to do the calculation twice in order to come up with this. Now, then the whole thing is how, where do you calculate this distance, and that distance? But at least right now, based on that, at least you should know how far this is going to shrink and how far this is going to shrink. Okay. All right. So we're going to leave you with. Hey, here's my hat. I'm going to leave you with this. I think you have another lesson right now, another class or not? Do you? Okay, cool. Thank you very much, and I will see you when I see you. Some of you I'm going to see you tomorrow during the lab. Thank you. Have a good one.